Hey guys, so in today's lesson, we're going to be talking about rational expressions and zeros. For this lesson, you're going to need station 1. You want to bring back out the factor pairs chart. You're going to need a pencil and you may want a calculator. And then in order to be successful in this lesson, you're going to need to factor. I'm not going to be putting anything that's too complicated to factor, but you're definitely going to need to remember how to do those things. You're also going to need to know how to find the domain of rational expressions. You're going to need to be familiar with certain vocabulary terms like asymptotes, zeros, x-intercepts, and so on and so forth. So let's get into example 1. There are no notes for this section, but if you want to annotate, feel free. All right, so we have the rational expression and we want to complete the table. Notice that I'm giving you the rational expression and I factored it for you so that we can understand what's happening before I ask you to factor. So we're going to go through the table one by one. And for when we're dealing with rational expressions, one of the first things that you tend to do is to factor. You're going to need to factor in order for most of these questions in order to answer them. So remember, our domain is all of our x values. And for our domain for rational expressions, it's always going to be all real numbers except where the bottom or the denominator is equal to 0. So besides factoring, we don't necessarily have to simplify this fraction. And I'll talk about what simplifying is in a second. All right, so we don't have to simplify. And then we just need to set the denominator equal to 0 in order to find out where it is restricted. All right, so our answer is going to be all real numbers except where x is -1 and +1. All right, so next, we learned about the vertical asymptotes. We learned that the vertical asymptotes are going to be where your function is undefined, right? But there's an extra caveat to that. First, you need to simplify. So looking at our factored expression, our x plus 3, x minus 1 over x minus 1, x plus 1. Notice that we have the same expression on top and the bottom. We have that x minus 1. Okay, so I can cross those out because they're the same on top and bottom. So notice that we're only left with x plus 1 at the bottom. That's the only part of the expression that we're going to use to find our vertical asymptote. Okay, so we need to simplify first. So we're going to circle yes. And then we need to use what's left over from the denominator of the fraction to find the vertical asymptote. Okay, so we're just left with x plus 1. We set that equal to 0. And our answer is going to be x equal to -1. Okay, next part, the holes. Okay, so far we know that a hole is a type of discontinuity. In order to do this, we must simplify first. And the value of our hole is going to be anything that we crossed out. So as we see here, we crossed out x minus 1, which means our hole is going to be at whatever x minus 1 equal to 0 is. My hole is going to be at x equals 1. Zeros. All right, so zeros are your x-intercepts. Your zeros are going to occur when the top part of your fraction is equal to 0 after you simplify. Okay, so we need to simplify, okay? And notice that that x minus 1 is gone from the top of our fraction. So we're only left with x plus 3. So I'm going to set x plus 3 equal to 0 and solve for x, which means our hole is only at x equals to -3. Our y-intercept. So remember, our y-intercept is where it crosses the y-axis or the value of y when x is 0. For this, we do not need to simplify. I'm going to use the original expression in order to do this. So I'm not using the factored expression. I'm using the original. So every place that I see an x, I'm going to put a 0. And basically, you're just going to be left with the constants at the end. Your y-intercept is going to be -3 over -1, which equals just 3. All right, and the horizontal asymptote. We talked about this in the last lesson. Do we need to simplify to do this? No, we do not need to simplify. And in order to figure out our horizontal asymptotes, we need to look at the leading terms of our fraction, of the numerator and the denominator. All right, so since our leading terms have the same number of x's on top and bottom, we're going to have our horizontal asymptote at the ratios of leading coefficients. So I don't see any numbers by my x squared, which means there's just 1 in front. Okay, so my horizontal asymptote is going to be at y equals to 1. Okay, so we're going to be using this table to help us answer the rest of the questions. So number 2, we're doing the same exact thing. And like before, I gave you the original rational expression and the factored form to make your life a little bit easier for now. All right, so for domain, we need to look at the bottom of the fraction and figure out where it's going to equal to 0. We see that our domain is going to be all real numbers except when x is -2 and +4. All right, vertical asymptotes. First, we need to simplify. So let's look at our fraction and see if there's anything we can cross out. So I see an x plus 4 at the top and then x minus 4 at the bottom. I cannot cross those out because those are not the same, which means our vertical asymptotes are going to be whatever makes the bottom of the fraction equal to 0. And that's going to be -2 and +4. Okay? Our wholes are going to be after we simplify if there's anything that was crossed out. For this problem, there is nothing that was crossed out, which means there are no wholes. So we can just put NA. Our zeros are going to be whatever makes the top part of the fraction equal to 0. First one is x equal to 0. Next one is x minus 5 equal to 0. And then the last one is x plus 4 equal to 0. I'm going to have 3 zeros. It's going to be x equal to -4, 0, and 5. All right, y-intercept. Your y-intercept, it does not need to be simplified or factored before you figure it out. To get the y-intercept, you're just going to plug in 0 into all of your x values. My y-intercept is 0. And then for horizontal asymptote, it does not need to be simplified. And we're looking at the leading terms. On the top, I have x to the third, and then the bottom, I have x to the second power. I have more x's at the top than I do at the bottom, which means there are not going to be any horizontal asymptotes. Okay, let's flip the page over. Now we're doing the same exact thing, but notice I did not factor for you, so you're going to have to do that. So let's go ahead and factor the top. We're looking for two numbers that multiply to 8 and adds to -6. You can pause the lesson and try to figure this out on your own. So you should have gotten -4 and -2. So the factored part for the numerator is going to be x minus 4 and then x minus 2. Then the bottom, you're looking for two numbers that multiply to 4 and adds to -5. So for that, you're going to get x minus 4 and then x plus 1. Notice that we have something that we can cancel out, which we'll do in a second. So first, we need to figure out the domain, and that's going to be where the bottom is equal to 0. All right, and that's going to be the set of all real numbers such that x cannot equal -1 and 4. Vertical asymptotes, we do need to simplify first. So we can cross out that x minus 4. Now looking at the bottom of the fraction, the only thing that's left over is x plus 1, which means we're going to have a vertical asymptote at x equals 1. The whole is going to be wherever we crossed out the expression. So we crossed out the expression at x minus 4, which means we're going to have a whole at x equal to 4. All right, our zeros are going to be at the top after we simplified our expression. So the only thing that we have at the top that's left is x minus 2. So our 0 is going to be at 2. Our y-intercept, we do not need to simplify for this. We need to use the original expression. We're going to plug in a 0 every place we see an x, and then you're going to be left with 8 over 4. And then you simplify 8 over 4, that equals 2. Horizontal asymptotes, we don't need to simplify, and we're looking at the leading terms. So we have 2 x's on top, 2 x's at the bottom, the same amount, so we're taking the ratio. All right, so that's going to leave us with 1 over 1, so our horizontal asymptote is y equal to 1. All right, number 4. Now we don't have an expression, we have a graph, and this graph is a rational expression, so we're going to be using this graph to answer the same questions. So since this is a rational expression, the domain is going to be all real numbers except where the function is undefined. We see that we have a vertical asymptote right here, and we have a whole right there. So our domain is going to be all real numbers except where we have that asymptote and that whole. So it's going to be all real numbers except when x is -3 and 1. Vertical asymptotes. This is pretty straightforward. We're just going to look where we see a vertical asymptote, which is at x equal to -3. The whole, we don't have to solve for anything. We see that there's a whole at x equal to 1, so we're going to write that down. Zeros, where the graph crosses the x-axis. So we see that it crosses twice, one at -4 and the other one is at 0. Our y-intercept, where the graph crosses the y-axis, that's going to be at y equal to 0. And then horizontal asymptotes. I do not see any horizontal asymptotes, so that is none, or NA, whatever you want to write. So number 5, we're going back to what we were doing before. I gave you an expression that is not factored. If you would like a challenge, go ahead and pause the lesson and see if you remember how to factor this. So the top part, we have x squared minus 9. That is a difference of perfect squares. So the top part factor is going to be x plus 3 and then x minus 3. The bottom part, I got to check for a GCF. I see that all 3 terms have an x, so I'm going to take out one of those, and I'm going to be left with x squared minus x minus 6. I can still factor what's left over. All right, so I'm going to, on the bottom, I'm looking for two numbers that multiply to -6 and adds to -1. That's going to be -3 and +2. My fully factored expression is going to be x plus 3, x minus 3 at the top, and then x minus 3, x plus 2. And notice we can cancel out those 3's. So now for our domain, it's going to be what makes the bottom part of our factored expression equal to 0. So our domain is going to be the set of all real numbers except where x is -2, 0, and 3. Our vertical asymptote is going to be anything that's left over in our denominator. We're going to be using x equal to 0, and then x is going to also equal -2. Our holes are going to be the value for anything that we crossed out. So we crossed out x minus 3, so we're going to have a hole at x equal to 3. Our zeros are going to be whatever's left over in the top part that's equal to 0. The only thing that we have left over after we simplify is x plus 3. So when you set that equal to 0 and solve, you're going to get x equal to -3. For our y-intercept, we're plugging in 0 for x. We get -9 over 0. So do we have a y-intercept here? No, we don't, because we have a 0 at the denominator, which means that it's undefined at 0. There is no x-intercept, which is what we expect, right? Because when x equals 0, we have a vertical asymptote. And then for our horizontal asymptote, we're looking at the leading terms. We see that we have 2 x's on the top and 3 at the bottom, which means there's more x's at the bottom than there is at the top. So our horizontal asymptote is going to be y equal to 0. Okay, so hopefully that's not a lot. If anything is a little bit confusing or confusing at all, please come and talk to me so we can talk through it. So go ahead and move on to the next assignment.